Welcome back, friends. Now that you have learnt about the different types of public transportation systems, be it bus, rapid rail, monorail, and also looked at some financing and marketing opportunities, and we have also introduced you to some intermediate public transportation systems. In this lecture, what we are going to look at is how do you measure the performance of transit systems, right? So, you have all these various types of public transportation systems on your city network, but how do you measure how well they are performing? How do you what are some of the parameters that you use to measure the efficiency or to measure the performance of these public transportation systems? Here we will give you an overview of how you can select these parameters based on passengers perspective as well as the transit agency perspective, and these performance parameters are related to fixed route services, right. So, any public transportation system that is running on a fixed route and not on a flexible on demand route. So, when we look at the entire spectrum of transit performance, there are 4 different viewpoints that are usually indicated, and those viewpoints are of 4 different stakeholders of public transportation. It starts with the passengers who use it, the transit agencies who operate it, the public works department which has to maintain the roads or the structures on which these public transportation systems run, and also the community at large. So, it is a very fine balancing act that has to be carried out in order to ensure that the viewpoints of all of the stakeholders are taken into account when you are measuring the performance of any system, right. Otherwise, one of the stakeholders viewpoints, if they are not taken into account, then it becomes a skewed kind of an analysis. If you only look at it from the point of view of, for example, the transit agency and do not consider the passengers point of view, or also it may become too onerous on the transit agency to implement certain measures if you look at it only from the perspective of the transit passengers. So, shown here in this table are the different stakeholders, their different interest areas, and also examples of corresponding performance measures. For example, if you look at the transit passengers, they are always wanting travel times that should be minimized during their travel. So, what a performance measure that can give you how well the public transportation system is doing is a transit to auto travel time ratio, right. Auto meaning your automobile, private automobile. So, if you know that in comparison to your private automobile, what is the travel time on transit, then based on that ratio you can make some decisions as to how well your public transportation system is working. Similarly, if you look at the transit agency as a stakeholder, they are always interested in the economics of how well the public transportation system is doing. So, one of the performance measures could be ridership, how many people are riding on the transit service. Similarly, the regular motorists on the highways, right. If these public transportation systems are sharing the road space, then the motorists, the other motorists also become a stakeholder. So, what are their concerns? Their concerns may be because of the public transportation system, they may be coming into some delay in their travel time, right. If there are large buses which often are obstructing the traffic flow because of several reasons, maybe the location of bus stops, maybe the time required to turn onto narrow streets, and so on and so forth. So, there is always delay to the motorist. So, you see all of the stakeholders' interests have to be taken into account while you are selecting the appropriate performance measure. So, here let us look at, in this lecture we will be looking at 2 such perspectives. One is the passengers perspective and the other is the transit agency perspective. So, when you look at the passengers perspective, you are essentially finding out what is the quality of the service that is being provided, because the passenger is always perceiving the qualitative aspects of the public transportation system. So, they can be broadly looked into, if they can be broadly grouped, they will be broadly grouped into two categories. One is the service availability and the other is comfort and convenience, right. As a public transport user, we are always worried about where is my bus. We are always worried if there is a service that is available at that time when we want to travel. If it is a late night, late evening travel, is the bus frequency good enough for me to get hold of the next bus available. Or the other thing is comfort and convenience, right. We never want to encounter such a situation where the metro is overcrowded and people are hanging out of the metro, or even the buses are overcrowded. So, we are always concerned about the comfort and the convenience when we take a public transportation system. So, if you include parameters that would judge the service availability and also judge the comfort and convenience, then we could determine the quality of the service from the passenger's perspective and hence evaluate the public transportation system's performance. So, we can say a public transportation system from the point of view of the users is performing well if it has less crowding, for example, or if it has high frequency, so that all the passengers can avail of the public transportation system. So, typical factors or typical parameters include frequency, wait time, right, reliability. We always want to be reaching our destination on time every time. If the service is close to home on the destination, crowding, and also fare and driver behavior and driver friendliness. So, these are some of the factors that are always helpful in understanding the passenger's perspective while you are measuring the performance of a public transportation system. So, if you start looking into each of these parameters one by one. So, the factors that will impact service availability include spatial availability, temporal availability, information availability, as well as capacity availability, right. We want the bus or we want the transit system to be available spatially meaning it should be available close to my home or to my destination. So, when I reach my destination or when I disembark from the transit station, my destination should not be very far away. Similarly, when I get on a bus or to reach the nearest bus station, the distance should not be very large. So, this kind of diagram shows you a classic example of how if the different transit stops are optimally located, then it kind of creates a system of stops, and this ensures that the transit usage is very high. So, accessibility and transit usage can be linked in such a manner where you are locating the bus stops optimally. If the bus stops are farther away, then the accessibility to the metro stations or the bus stops is less, the accessibility is less, whereas if the accessibility is less, then the transit usage probability is also low. Similarly, we also want temporal availability, right, time of the day. We want public transportation systems to be available almost if not 24/7, right. We want it at late at night, we want it early in the morning, we want it in the middle of the day. So, we always, one of the things that is always requested is night services, right. Many of us work late at the night or work night shifts. For all of such people, night services or owl services you will maybe refer to, you must have heard that terminology. Many of them refer to as owl services, and that becomes very important. Next, we would also want information availability, right. Nowadays, information is not only available at the bus stops or at the transit or at the metro stops, but are also available online. If you have online schedules, if you have real time data about where the next vehicle is, everything can be tracked online. So, the more information availability, the better is the perception of the passengers about the quality of service that is being provided by the public transportation system. Also, last but not the least, we also want to know the capacity availability. Now, we want to know it but unfortunately we not always know that whether the next bus that is coming or whether the next metro rail that is coming would have a seat for me or not, right. You cannot reserve a seat in urban public transportation, just as you can reserve a seat in intercity public transportation, whereas in urban transportation you cannot reserve a seat. However, this kind of a situation is to be avoided, and so if you know what capacity is free, whether you can get a seat, even if you have information that whether you will be able to comfortably stand, that is also good information to have, because many people do not mind standing as long as there is comfortable space, comfortable maneuverability within the bus or the metro system. So, those are the factors that are usually looked at when we are trying to identify service availability. Similarly, if we next go to the factors that impact comfort and convenience, these are very intuitive factors, as many of us think about this every time we plan to take public transportation or are taking public transportation. One is in vehicle crowding, you are always worried if I can get a seat. Reliability of the public transportation system, can I expect to get to my destination at the scheduled time, or should I give myself a buffer, right. We always think if I have to reach a destination at 9:30 in the morning, should I take a bus that leaves my home at 8:30 and reaches there 8:45, giving me a 15-minute buffer. So, that buffer time is always calculated in our head in order to make sure that if the bus is not reliably on time, then I still have some extra time available to me to reach my destination. Travel time, of course, we always look for comparable travel times on public transportation versus private transportation, right. This is one of the drawbacks public transportation always has, especially public transportation modes that share the right of way with other vehicles. People are always skeptical that they always take longer time to take you to the same destination as compared to your private automobile. Here again, door to door trip is very important, because when we are talking about travel time on public transportation, it is not only the time that is spent in the vehicle, but also the time spent waiting for the vehicle to come, and in case there are transfers, you have to transfer from one vehicle to the other, then the time taken in the transfers is also has to be added on to the in vehicle travel time. So, the total travel time is to be calculated. Similarly, access environment, do I have good access to the transit stops, can I easily reach there, is the for example, is the sidewalk network good, or is there enough parking there so that I can park my vehicle, what is the cost, out of pocket cost, safety, security and amenities, driver friendliness, etc. So, these are kind of the factors that affect the comfort and convenience from the point of view of passengers. Finally, now if you start looking at the factors and incorporate the transit agency perspective, then you will again see that the broad two factors kind of remain the same, right, availability and comfort and convenience, but now you start looking at individual factors such as frequency, service span, access and also passenger load, reliability and travel time from the point of view of the transit agency as well, right. So, frequency. So, when we talk about frequency, we are talking about essentially how many vehicles or how many transit vehicles are arriving at a particular stop or a location within a time span of say 1 minute or 10 minutes or half an hour or 1 hour, whatever it is. So, we want to know how frequent the service is. From the passengers perspective, we want higher and higher frequency, but from a transit agency's perspective, higher frequency meaning more number of buses for it to operate and higher operational charges. So, how do we balance these things, right? Transit agency would not want to incur higher operating charges, whereas from the user's point of view or from the passenger's point of view, I want high frequency services. So, that is where you have to balance the transit agency perspective as well. So, let us look at each of them again individually, starting with availability and the three factors: frequency, service span and access. So, when we talk about frequency, like we said, ridership increases as frequency increases, right. More frequently, more frequent is the bus service or the metro service, more number of people are actually using it, but frequency affects operating costs as well. Service span, long service span serves greater number of people. Service span meaning just how many hours in a day does the public transportation system run for, right? How many hours in a day or how many days in a month or so on and so forth. So, that is the service span. So, service span, although if you have longer service hours, it will again result in higher ridership, greater number of passengers taking it, and it will also determine how well of a market you have captured, the public transportation has captured, right. So, it can not only increase the ridership, but it can also cater to new market segments. So, you suddenly put in another line, new line in another part of your city and you capture that market as well. But again, the user transit agency's perspective would be to put in these new lines or to improve the or to increase the service span during a day. Operation charges goes up. Similarly, the third one is access or service coverage. In this time we are looking at how well public transportation system can be reached either by walking, bicycling or automobile access, how good the terrain, connectivity and densities are. Again, remember we showed you the we just now showed you the location of the transit stations or bus stops. That depends upon how dense the population is. Most of the people who are accessing fixed route public transportation systems usually get to the stops by walking. If there is a parking available, they use automobile access, and now there are more and more people who are trying to bicycle. So, how good is the access to the public transportation system determines how much coverage it is able to attract, how much coverage area it is able to attract. So, now there are several thresholds that have been developed, so that you can easily quantify all of these measures, right. Unless you are able to quantify, again it becomes, if it becomes only qualitative, then it becomes very subjective, and it may be difficult to for example, develop budgets for these kind of things. So, we always try to quantify it. So, when we try to quantify frequency, this is for example developed in as a part of the transit capacity and quality service manual TCQSM in USA. So, these may not be directly related to Indian situation, but again you have to understand how these are developed, so that you can either adapt it to Indian conditions or develop your own set of measures or parameters and then their ranges. So, what this particular range says that if your frequencies your frequency could be of any one of these levels 1, 2, 3, 4, 5, 6 or 7. So, they have quantified it at 7 different levels ranging from a very high frequency of less than 5 minutes to a very low frequency of greater than 60 minutes or only one vehicle per hour. So, what does this mean? So, for example, when you are developing such ranges, you always have to try to qualify or quantify any of this. So, when you are saying that your frequency is anywhere greater than 5 minutes, but less than 10 minutes, what we mean is that frequent service, no need for passengers to consult schedules. So, there is no need that a passenger has to look at a bus schedule. He or she can just come at a stop and will get the next vehicle very quickly. So, that is kind of the scenario when the frequency is between 5 to 10 minutes. Bus bunching is possible. So, then if such high frequencies operate, it is good for the passenger, but when it comes to the transit agency, they may face bus bunching, right. Bus bunching is where 2 or 3 buses come very close to each other, or their schedules merge. So, they are very close to each other, running in bunches. So, that is a bad situation which can result in longer than planned waits for a bus and more variable bus loads. Now, suddenly if that 2 or 3 buses arrive at the same time, then for the next bus to arrive, it takes a longer period of time. So, when there are such high frequencies, bus bunching is possible, which should be then avoided. So, from the transit agency perspective, such high frequencies are only feasible on high density corridors with bus or rail service where routes converge to serve a major activity center. So, such kind of services, if you are planning for such kind of services, you have to look for major activity centers that are connected, right. So, this is a very, I mean, through various examples, what we are trying to let you know is all of these factors or parameters have both a transit agency perspective as well as a passenger's perspective, right, and they can be then converted into different scales that will allow you to then gauge the performance of your transit service. Remember, we talked about levels of service earlier. So, this is very synonymous to a level of service, but many of the transit agencies usually do not like the letter grade A through F kind of a grading, because they feel it is too academic or too much like a classroom. So, they do not want to give their operators a grade. So, rather than giving them a grade, we have only divided them up into levels. You could have easily given this an A and this an F, but we are not doing so, right, we are not doing so. Similarly, for service span, so you can break it up again into different levels 1, 2, 3, 4, 5 and 6 levels. If you have a service span that is greater than 18 hours a day. So, the public transportation system is available more than 18 hours a day. A full range of trip purposes can be served from the passenger's point of view, allows bus travel to replace potential riskier travel. So, crime, you can avoid drunk driving, poor visibility at night can be avoided, or driving in poor visibility can be avoided, and public transportation can be taken. However, from the operator's perspective, sorry, from the operator's perspective, this may require added driver payment for late night work, right, that may increase the operating cost, may only be offered on certain days. So, maybe only on days when night services are required, for example, it may be offered. May require increased security measures, especially if nighttime travel is involved, you may want to have higher security. So, these two perspectives, passenger perspective and operator's perspective, have to be balanced when you determine how much service span you provide. Similarly, the next one is service coverage. Like we said, service coverage is more people located within the given area. So, what is being seen is that the greater the household density along the route, the greater is the overall transit demand. So, household density and transit demand are kind of go hand in hand. If, for example, if the household density increases from 2.35 to 4.7, you see that the overall transit demand increases 4 times. Overall transit demand consists of not only the number of people or number of households, but also the likelihood of using transport. So, you can have higher number of households, but if they are not likely to use it, then you will not have such a high demand. So, you have to have both. You have to have higher number of households or household density, and that in turn will give rise to the likelihood of using public transport, right. So, both of them together gives you the overall transit demand. So, it is also shown that if 90%, so this could be you could provide coverage up to 90% of the population to be served. You could provide service of 90% not of the population, but of the transit supportive area. So, transit supportive area again meaning around the metro stations or around the bus nodes or the bus stops, that kind of a area, or 75. So, you can have again different levels of this. All different levels will depend upon what the transport agencies or the transit agencies can support based on their budget, right. This definition of transit support area is based on the fact that at least 3 households per gross acre or at least 4 jobs per gross acre is available, and also 33% of the fare box collection is recovered from the services. These are assumptions that are made as per the conditions in the United States, that could be altered for our situation as well. Similarly, now if you start looking at the comfort and the convenience part of it, we have already seen that there are 3 aspects involved: passenger load, reliability and travel time. Interestingly, passengers value of time increases with the level of crowding. As soon as more than 80% of the seats are occupied, people inherently start to believe that the time taken on the public transportation system will be higher than my private automobile. Hence, I should use my private automobile because my value of time is greater, right. So, people always value time in terms of cost. So, if the time taken on a public transportation system is longer, then the value of time for me goes down, right. I do not want to travel in a bus that stops at every stop and it takes me longer time. So, but empirically it has been seen that 80% as soon as 80% of the seats are occupied, the person getting up on the bus immediately starts thinking that, well, it is already crowded, that means the road should also be crowded, that means the travel time will increase and my value of time will also increase. Cost effectiveness increases, but on the other side, from the point of view of the transit agency, cost effectiveness increases as passenger load increases. So, transit agency always wants more and more people on the bus, right, or bus or metro. Similarly, reliability, passengers, should they allow extra time for their trips or not. Unreliable service, from the point of view of agencies also, unreliable service is not good because it inserts more recovery times in their schedules, right. So, at the end of the trip they have to add some recovery time, and hence by adding recovery time they are not the buses are actually not running for revenue collection, but whereas they are sitting idle and not earning any revenue. So, if there are unreliable services, the recovery times are higher, which is not good for transit agencies. Similarly, travel time, when it comes to travel time, transit travel time versus travel time on other modes is a crucial aspect in mode choice. People always make this balance that if I travel on private my own vehicle versus on the public transport, what is the difference in travel time, and if the difference if they can justify the difference, only then they take public transportation. Operating costs are also directly involved. So, impacted by transit travel times. If there is so much congestion that the buses cannot keep on schedule, then they are actually making less runs in a day. If they make less runs in a day, their actually revenues are lowering. So, all of them again you see have the perspectives of both transit as well as passenger. So, again individually if you look at them, there are levels that each of the services can be divided up into. So, for example, passenger load, up to 50% of the seats are loaded, that has a different. So, here the example is given of up to 125% of the seats loaded. So, in this case standees may need to shift position within the vehicle at each stop as other passengers board or alight. So, it is overcrowded, it is more than 100%, 125% occupancy the bus is running at. That means people are standing, but not only are they standing, but they are also have to shift their positions when people are trying to move in and out. So, this gives you an indication, right. This gives you a measure for how crowded the situation is. So, that may not be very good for passengers, but such a service may be very productive for the transit agency. So, how do you balance it? Do you say that I should run at 125%, or you say that no, that is causing a problem to the from the passenger's perspective, and so I should not run. So, that is the kind of balancing activity that has to be carried out. Passenger load levels, standing levels are also there are thresholds that can be developed. For example, during crush loading there is very less space, right. There is very less, either less than 2.2 square feet per person, or which is less than 0.2 meter square per person. That is called, so everybody is crushed against each other. So, there is very little space, standing space also available. So, even for transit agencies it becomes difficult, because moving to and from doorway is extremely difficult. Then the dwell times also increases, right, increasing dwell time meaning the buses that wait at a bus stop to pick up passengers also increases, because now the passengers inside the bus have to be shifting to get on and off the bus. So, it takes it increases the dwell time. So, passenger load levels also have to be determined in order to understand how well a public transportation system is performing. Similarly, reliability, again, reliability means on time performance, right, applicable to service that only operates on fixed schedule, defined as departure no more than 1 minute early and up to 5 minutes late. So, if your transit system is performing or a vehicle is coming up to 1 minute early or no less than 5 minutes late, it is said to be on time. So, if there are 100% of such vehicles, of all the vehicles are arriving within this time frame, then you say that your system is operating at a 95 to 100% performance. So, that is how again each of the perspectives are given in this table. Similarly, travel time, remember travel time is in this case is always measured as a ratio, transit to automobile travel time ratio. As the ratio increases, it becomes tedious for all riders. Nobody wants to take a public transportation system that will take twice the amount of time, right, as your private vehicle takes. So, if it takes you 30 minutes on your car and if it takes 60 minutes on public transportation, then obviously you are not going to take your public transportation. Lastly, we will get into this in the coming lectures, but just to give you a glimpse of what is happening in the Indian context, there are several such service level benchmarks that have been developed for urban areas by the ministry. 10 such different facilities or services have been taken into account, and all these levels of service have been identified for each of these 10 services or facilities, right. So, here is an example of the first one, public transport facilities. So, the levels of service of public transportation facilities are calculated based on 6 different parameters, and the overall level of service is just the addition of all these individual levels of service. You finally get a score, this is your score, and based on the score an overall level of service is given. For example, presence of organized public transport system in the urban area. If there is no organized public transport system or less than 20% of the urban area has organized transport system, then you get a level of service of 4. Similarly, if the level of comfort in public transport is greater than 2.5. So, how do you define level of comfort? We will all get into all of that. How do you calculate each of these? We will let you know in the following lectures that come up, but you should know that there are such SLBs. So, they are called service level benchmarks that are being developed for the urban areas in India, which will allow you to measure the performance of the public transportation systems. So, the references are given here. Majority of the materials have been adopted from the transit capacity and quality of service manual, and it can be freely downloaded at this website. So, please do look at it. So, in conclusion, in this lecture we looked at measuring the transit performance both from passengers and transit agencies point of view. If there are objectives are conflicting, an optimal situation and an optimal state has to be arrived at without harming any one of the stakeholders. passengers are always interested in high frequency, less crowdedness and comparable and reliable travel times, whereas transit operators have to ensure optimal passenger load, on time performance and schedule adherence in order to sustain their services. Thank you very much.